Hello. Good afternoon, everyone. Welcome to the Marker Lectures for 2024. So first, a couple of words about the Marker Lectures. The Marker Lectures were established in 1984 through a gift from Russell Earl Marker, who was a professor emeritus of chemistry here at Penn State, whose pioneering synthetic methods revolutionized the steroid hormone industry and opened the door to the current era of hormone therapies, including the birth control pill. So in case you didn't know the roots of the Marker Lecture, it's very interesting. So with that, I'd like to introduce our Marker Lecturer this year. It's Professor Xiao-Li Meng from Harvard University. He's the Whipple-Jones Professor of Statistics at Harvard. He's been very influential in a number of areas of statistics, including Bayesian methods for goodness of fit and model choice, philosophical and foundational issues in statistics, statistical computing, including both Markov-Chain Monte Carlo and expectation maximization algorithms, and multiple imputation. And those are just the topics where he has massive numbers of citations. He also has very serious interest in many other fields, disciplines within statistics, including applications, interdisciplinary research in astronomy and psychology and psychiatry. His range of interests is truly remarkable. In fact, I remember at the end of a talk he gave here at Penn State recently, there were faculty in our department, a whole number, who were waiting to talk to him, who knew him through common research interests, and those research interests were, at least the ones that I remember, astronomy, data privacy, statistical computing, statistics education, and I think there were a few others. That's quite a remarkable variety of things he's interested in. And somehow, with all the things he works on in research, he still found the time to be an important participant in conversations about data science and the future of our profession, also to serve as Dean of Arts and Sciences for a number of years, and to serve as the editor-in-chief of the Harvard Data Science Review, which is a journal he actually founded. He will give two talks, the more public talk today and a more technical talk tomorrow at 11 a.m., also in 101 Thomas. His talk tomorrow will be on statistics foundations and on things related to imprecise probability. One quick note, as we do in these talks, we will have a Q&A at the end, which will be moderated by two of our PhD students, Wenlong Yang and Wan Gu. And there's a Slido up here that you can keep note of, and you can start sticking questions in as and when you think of them. And with that, please join me in welcoming Professor Xiao-Li Meng.
Thank you. Thank you very much. And I always like to use this because it feels like I can sing karaoke. So I'm actually really giving 3 talks. So you kind of buy 2, you get 1 for free. Okay. I'm actually today will be really 2 talks that each hopefully is a half hour or less than a half hour, because both are all on the same topic about data quality. All right. So I'm going to start with the first one, and hopefully this is right. Okay. So I use this phrase called data mining. I'm quite sure that very few of you have heard that term until probably this talk. And if you put data mining in Google search or anywhere, you're going to get a suggestion that this should be data mining. Okay, and then you can try that. And even if it doesn't correct you, it will, if you're writing Word, it will tell you that this is probably something wrong. It's so funny that I was just going to Google myself. I put in, say, data mining before data mining. It comes back, say, the suggested search is data mining before data mining. Okay? So the point I want to make is that is actually the real problem why I want to talk about data mining, and you're probably going to guess the idea here is we need to pay a lot more attention to the data quality. With the advance of all these incredible tools, now we have ChatGPT, generative AI, there are incredible tools to finding patterns. But they cannot find the patterns that is not in the data, right? Now, as a human, that if I say something data mining, and it's particularly for those who know me, they probably know that's what I actually meant. Some of you know that I like to play the word games. You know, you probably, I'm doing those. You would have guessed I did not mean data mining. But for these software, for these algorithms, there's pattern seeking, right? It's obviously, statistically speaking, it's a lot accurate prediction to think that what I meant was data mining, because that's a very common phrase. Data mining is seemingly just like a typo, right? So the thing is, like, these algorithms, they're doing the right thing because they're meant to find the pattern, and to find the pattern means that something is more likely than not. So the issue then here is that if our data are subject to all kinds of errors, and you cannot blame these algorithms to come up with things you don't like, or it does not solve your problem, right? So the whole point today I want to talk about is how we, statisticians particularly, should pay a lot more attention to data quality. Now some of you may say, Xiao-Li, we statisticians always pay attention to data quality. Yes, you're right. But there are areas that we have not paid that much attention. We pay a lot of data attention to, for example, the data collection methods, right? Lots of us are working on missing data mechanism. All those things are important. But if you really think about data science, it is very broad, from very broad perspectives. There are many other processes the statisticians usually don't pay that much attention. Frankly, it's not even our job. For example, data management, data curation. There's a lot of those things there are other few take care of that, and it's called computer science, okay? Now, I want to emphasize one thing that, let me actually say this way, because, let me first say, how do I get to this particular topic? I was asked, so the first part was really the 2021 article. I was asked by the journal, by the Royal Statistical Society Journal, Series A. Most of you publishing B, there's a Series A. A is a much more kind of a societal phase. They try to publish special issues on data science, okay? And they invite me because they knew that I was writing about, I write editorials for this Harvard Data Science Review, which you're going to see a little bit today. And I write a kind of thematic editorial. They like it. So they say, Xiao-Li, can you come to write an editorial for our special issue on data science? Okay. And I told myself, say, well, this could be fun. And I told them, like, be careful what you wish. Okay. So what I had in mind was the following. Everybody now jump on the wagon of data science and now AIs, right? I want to know whether these articles are really data science articles or they're just statistical articles, but they call themselves data science. Okay? So I give myself a job, so I'm going to read every article and I want to really study whether they are really data science. Of course, you're going to ask me, what's the difference between data science and the statistics? So I'm going to tell you that. And the first part was, this was end up become a commentary instead of editorial. I was a lot more critical and a lot longer than they expected. And I'm going to tell you why, and then where I called a creative work called data mining, as well as create this thing called a data confession, meaning that you should really write as much as possible, not about how great your data set is, but all the defects in your data set, all the decisions you have to make because the data are just not as good as you hope they are. Okay? So, but let me first really talk about, talk a little bit about Harvard Data Science Review, because I use quite a few articles there to set the theme, what is data science? Now, obviously, I'm advertising here as well. It's an entirely free journal. It's called a Diamond Open Access. Some of you understand the difference between Diamond Open Access and Golden Open Access. You look puzzled. Okay, Diamond Open Access means we charge no one, not even authors. Okay, so our slogan is everything data science and data science for everyone. So the first thing, for the first issue, this is now 5 years, again, feel free to check anytime, not now, but later. The first issue, people told me, like, Xiao-Li, you have this very ambitious project trying to create this journal to basically to help to define what is data science. So I better first to ask people to write what is data science. So the first person I ask is Jeanette Wynn. Some of you may know her and others may not. And she is a computer scientist, very well known for her contribution, many contributions, but one of the key contributions, she's the one promote this idea called computational thinking. We have all the statistical thinking, but a computational thinking, they're different from statistical thinking, right? And she, at the time she wrote this article, she was the director of the Data Science Institute at the Columbia. She did too well, now she's the vice president there, okay? So she wrote this article, very short, there's no mathematics in it. In fact, the 75% of article in Harvard Data Science Review has no Greek letters in it, okay? So that's for the people to read. And so she wrote this article, said, she called it the data life cycle. She talked about generation, collection, processing, storage, management, analysis, visualization, interpretation, okay? That's the whole process. When I look at it, I say, wow, that's to me pretty good, okay? That's pretty good. But you can see that is part of them, we statisticians do a lot. Certainly analysis, collections, right? But we don't do much about, we certainly don't have expertise. We don't teach them processing, storage, management, right? We maybe do quite a bit of visualization now. We also do interpretation, right? But you can at least see this is certainly broader than the statistical, typical way of thinking about data science. Now, you see I put her in the center, there's more pictures coming. When I give this to others, for example, give to a philosopher. Again, every one of them have done great things, but you probably don't know. She wrote the article, she looked at this and said, Xiao-Li, there's something missing before any of them. Which she talked about is the data conceptualization. The idea is you need to conceptualize what you want to collect, what the question to ask, all those things. That's not just data collection. It's one way to think about is very much like for those of you who have taken a survey class, sample survey, before the survey, how to sample people is one thing, but how to define a questionnaire is another, and define question is incredibly important. I'm teaching a course on that as well. You can even, not just how you word this question, you can obviously lead or mislead people by the questions. Even how you order the question can change the answer pretty dramatically, right? I have all these real examples, but I'm not going to talk about that. But the fundamental point, and she's a philosopher, her point was there's no such thing is raw data. You can read her article at this point in raw data. Now, I agree with her in general, right? Because particularly in social science, lots of things like opinion surveys, we don't know what the raw data means because of how you ask and a lot of things. But I ask her questions like, for example, I can count how many people in this room. Hopefully I can count, right? Not every statistician can count. You probably know the joke. There's three kinds of statisticians, those who can count and then those who cannot. You have to laugh. You get it, right? Okay. So I asked her, what is so not raw? Like if I count like how many, let's say, I don't know, 100 people. That could be precise raw data. And she said to Xiao-Li, said, you're right, but think about why you're collecting the data from this room, not from other rooms, right? Because your intention of collecting some data itself should be part of the whole thinking. Because in the end, the interpretation of our results, and we all know selection bias is the one kills everything, okay? And in fact, as you know, what you think about what's happening in this country these days, there are lots of selective reportings. Not people lying, they tell you the truth, but they just don't tell you the whole truth. That's why in the court, you have to swear, you tell the truth, nothing but the truth, right? So that's the reason. So to them, the philosopher was thinking about the intention of everything. Okay, so the reason I'm emphasizing this is like when you think about the data science as the whole, you already start from thinking like the philosopher's thinking, which most times we don't really think that hard about, is a part of the data science because at the very beginning they can influence the results. All right, so I thought it was pretty good. I said, okay, I'm going to add in conceptualization at the beginning, except that when I send this to another great scientist. A data scientist, you probably don't know her. Chris Spokman, she coming from life science. Coming from the library science and information science. And she looked at the picture and she said, Xiao-Li, you missed the entirely what she called the lives and the afterlives of the data, right? Because often when we collect data, we do analysis. That's not the end of the story. There's a whole this notion called replicability crisis, reproducibility crisis. Well, if you want other people to replicate, to reproduce, you've got to tell other people what your data are, but that's not the only part. You need to tell other people all the decisions you made. And then anyone who analyzes data, you know how hard that is to record all the decisions you have made. None of us do that well. So there's a whole the discipline worry about the data curation, like how and data provenance, and all these things about how to preserve the data for future use, how do you retrieve the version control, all sorts of stuff, right? And that is squarely part of data science, but we don't really emphasize that much at all, right? Okay, so I'm sure this is not the entire picture. If you ask somebody else, there'll be other things to consider, but I'm just trying to give you a spectrum. By the way, all these articles, they're all short, not long. In the first issue of Harvard Data Science Review, I'm obviously advertising, so please read, okay? You will be inspired. I was truly inspired. So how inspired I was, because I took this classification, so when I start to read these articles, there were like 8 articles in this special issue, I decided the following. I want to see each of these articles, how much they devote, what's the percentage of article devoted to each of these categories, as a way to try to see how much these articles are mostly like a statistical article, which will be focusing on analysis, maybe some on data collection design, okay? So that's what I set the job for myself to do. And I basically, from there, I wrote this whole commentary, but since I'm the one who defined what data mining is, so I know it's a little bit obnoxious to quote yourself, but since I will define it, so I'm going to tell you what I had in mind. So basically for me, the data mining process is to treat data as a product in and of themselves. The point I want to emphasize is that we statisticians typically treat the data as our input, and our job is analyzing and get information as the output. We rarely treat the data set itself as the final product. In this whole data science pipeline, there are their job is to create a database. They don't analyze it, okay? Although, in order to create a relevant database, they should know they should anticipate what kind of analysis will be done later, okay? But their product itself is the database. So I want most of them start thinking about, forgetting that we have a chance to analyze them, how would we treat the data set? Because the one problem that when you have a chance to analyze them, you will think, yeah, I'm going to correct all the problems later, right? If the missing data, I'm going to do imputation later. If the things are not representative, I'm going to use weighting methods later, right? But imagine yourself like giving a data set, and I want to see like if I'm stopped here, if all I'm going to produce is data set, how do I make sure the data itself is of the great quality? Right? So this is what I emphasize: to treat data as a product in and of themselves, and accordingly subject them to data mining, by which I mean a stringent quality inspection process that scrutinizes the data conceptualization. You can see where I get the phrase: data pre-processing, data curation, data provenance, in addition to data collection, which is the traditional object or emphasis before data analysis. We do well on data analysis as well as on the data collection, but there are all the other processes. Okay, so now I'm going to use this itself as an example to see how hard this thing is, if I can move this in here. Okay. So here's what happens, and I think that probably happened to many of you, particularly all these faculties who got an invitation, you got invited to write something, you say yes, you think the deadline is so far away, you don't do anything, you forgot it until the last minute. People say, where's the article? Okay, now you're right. But in my case, it was even more complicated, because I set to do this study myself. I want to study these 8 articles to see what percentage of each article is devoted to these topics. So I immediately run into a data collection problem, even a data conceptualizing problem. Okay? I'm going to go through this with you because this is part I call data confession. You're going to see how terrible job I did because I was under the time pressure, literally. But what's important is for me to report them, because otherwise you look at the data set, whatever the subsequent people to analyze them, they have no idea what I call, for example, what do I mean by data visualization in an article, right? You may say, oh, that's easy. No, that's not easy. Think about how do you define something is data visualization. So what I did is for a variety of reasons, first you need to, remember I have so many different parts that of course I cannot do every part, so you start to group them, right? The grouping itself is a decision, obviously, right? You can do well, you can do poorly, and I'm trying to group them so I can have at least some amount of data there. So I grouped them and I grouped the concept validation and the collection together, which may or may not be right. But for this purpose, it's probably not too bad. So I collected them into like pre-processing, management, storage, right, so on and so forth. Okay. So firstly, you already have a problem. So how do you categorize things, which is a decision. The next one is really hard, which is when I say the percentage of an article, what I'm talking about, what's the unit here, right? That's not easy. Now, of course, these days, with all the people can do all the fancy stuff, they say, well, Xiao-Li, don't do it manually, you do a text mining, give to the thing. But for me, I only have a few days left. I don't do text mining. I barely touch the computer now other than the email, so I'm going to have to do manually. So it's constrained by the limitation I have. So what do? I need to come up with the units that are easy for me to collect. Now, there are many choices here, right? Let's see. Oh, this is even, okay, the conceptualization is even a problem. For example, there are papers talking about extracting keywords before they do data mining. Is that a pre-processing step or is that an analysis step? Lots of people think about, I'm extracting feature, then I do analysis, so that's a pre-processing. But all statisticians know, when you extract the feature, you pretty much define what the sufficient statistics is. Anything you did not extract is already gone, right? So that's clearly, it's an analysis choice. But how do I decide which way to put it? I put myself a problem I call pre-processing analysis. I don't know where I put it. So I made a decision, and I need to confess here. I said that I'm going to put it in both categories. Okay? But that's a decision, right? If you don't know that, you will say, why the data doesn't even add up with 100%? Because I have overlaps. But that's a decision. I just want to illustrate that there's all kinds of those things that lots of decisions are being made during even a very simple analysis, right? And this one's not entirely trivial. Essentially, is a kind of text analysis. Okay, so that's like a pre-processing. That's a conceptual issues. The other issues like what units should I measure, right? And when I was teaching this using this, I'm going to have fun with students. Since I don't have much time, I'm just going to say what I did. And so there are many choices. You can look at the words, okay, sentences, paragraphs, pages, sections, right? When you run out of time, what do? You use the largest unit, which is what? Well, section become too rough. I tried because section, there's some people that don't even have much section. So I use pages, okay? But page itself is not easy. What if there's only 2 sentences on the page? Do you count it? I did. I just wrote down, I did the most generous interpretation, right? Just 2 lines, even when there's a dangling paragraph there, I counted it. But that's a decision, right? Okay, and it turned out to be even more nightmares. What I got these was preprints. Everybody used different files, different pages. Right? So even I ended up using pages, but you know how much errors there. Right? I'm using this as really just it was realistic because I had to finish it, I had to do something. Right? But you can see in practice, most people know, if you're reading applied work, you spend the most time, 80-90% time, is cleaning data, making all these teeny-gritty decisions. Unless you're writing a paper called Data Confession, you can't even write about those things. Nobody read them. I can read them because I'm talking about Data Confession. I can write this as an example, right? There's a lot of little decisions, but they all matter. Okay? Now, there's something was too low, I just call it L, so these are the page number. Essentially, the fraction is how many pages that's devoted to that. And what is data visualization? How do I look at, what should be counted as data visualization? Lots of papers has, figures, graphs, right? But that's not a visualization. I think for anybody do data visualization, I tell them that data visualization means you have some figures and plot. That's a serious insult to them, right? Data visualization is a lot of work there. But because I was on out of time, and there's not anything else I can do, I don't quite understand. All I did, I just called how many pages contain figures and a graph. You get the picture, right? Okay, so now, after all this stuff there, I come up with a pretty impressive data set, right? But now just see how many problems there. Now, seriously, from a data set you can see, even with the data set with all the problems, you do see that most papers focusing on analysis method and results interpretations. There's only one article, the kidney disease prevalence ones, seems like have since across all of them. Okay, and most of them are, data collection has quite a bit, even with this. So you get the general picture, like these articles are pretty much still statistical papers, which is not surprising. Now, of course, someone will say, Xiao-Li, now, you do this, you tell us there's all these problems, how do we trust your conclusions? And I say, no, you don't have to trust my conclusion. Because I'm being very transparent about what I have done, you can make your own judgment. Okay, you get what you get. You can go to see it. I think my conclusion was pretty, it's not that much a conclusion because we know that statistical journals, they mostly publish statistical articles, right? Okay, so, but this is what I meant by a process of data confession, isn't it? Because we need to write. Now, most people will not do this, and I don't blame them. First, not a single person doing everything, okay? Second, there's not much incentive to disclose all this stuff. What's going to happen to the review? The reviewer is going to say, well, your data is garbage, or clean them up, right? Okay? But I think the realistically speaking, that if we really take science seriously, if we're really going to rely on all the tools, just let the tool automatically search for patterns, we have to pay a lot more attention to the data because once whatever data sits there, these tools, the tools are not going to do the data mining job for us. Their job is to do data mining. Seeking the pattern. All right, so that's later. The second part of the talk, I want to show you how devastating it can be when you don't pay attention to the, to the data quality. So now, what I want to do, basically what I did is, remember there was 8 articles. I read every articles. From every articles, I pick up something. I was being pretty picky. Pick up something about an article that I think they should have talked a lot more in terms of data quality. And what I'm blaming here, I do blame someone. I'm not necessarily blaming the author. I'm blaming the editor and the reviewers. Okay? There's things they should have picked up. Now, I took that perspective because I was the editor to write this thing. I'm partly saying that our editorial process or review process should pay a lot more attention to these issues. Even just do the following, right? You see that it's very hard for you to publish a statistical article in a statistical journal without describing clearly what the methodology is. When you're publishing a substantive journals, you write briefly about what the methodology, or maybe even as an appendix, you write what the result is. But I think that we should all have a section which say, talk about data quality, okay? You shouldn't talk about data quality. So what do you know about the data? What do you realize this thing? And we barely do those things. When some articles do that, often as a kind of afterthought, say, well, there's a limitation of the data, so on and so forth. But I think that we as a journal, as a field, if we take this thing seriously, which I don't know if people do or not, that we should have sections devoted to say, talk about data quality. Even just say everything's great, talk about it, okay? Because I doubt you will feel very confident to talk about your data is great. All data is incredibly messy. And if you don't know, just say you don't know, right? So I want to just go, because in the time, I have 4 examples. I think I'm probably only going to talk 2. This is the one probably is most relevant for now. Unfortunately, with these days, the whole notion of terrorist has been used for all kinds of rhetoricals, right? And so when I initially saw this article, what's come to my mind immediately, just reading the article title, I said, wow, how do you define terrorist? Now you may say, well, terrorist is easy. Well, it's not easy, okay? You guys probably know how it depends on which side you're on. You're claiming the other side is terrorist, right? Now, so I show you what this article wrote. And the article is great. It's an article actually, this methodology, everything is really quite good. It's a competition efficient, high dimensional. You know, these titles are pretty attractive, right? Something about methodology is kind of a very relevant, very big, and then apply to something kind of the general broader interest. So what they did is, this is what they actually wrote, right? They used a database. Those people did not collect data. These people recorded terrorist events since January 1st, 1970. And during that period, they reported that a number of researchers were employed to collate and record events from numerous domestic and foreign reports. Okay, number one, you see how they're going to collect the data. These were the researchers collected these reports. Okay, and here's the part that really got my attention, and this emphasis is mine. And this is a paragraph from the paper, and they actually just report what they learned from the literature, from say, during this period, an event which came to the attention of the complier was valid for inclusion if it involved the threatened or actual use of illegal force and the violence to attain a political, economical, religious, or social goals through fear, coercion, and intimidation. This boldface was mine. I was asking myself, what kind of data collection method is called come to my attention? What's that? How do I analyze the data as come to my attention? Come to the attention. Come to whose attention? Well, that's not the author's fault. They basically wrote down whatever in the literature, right? What I find was really disturbing was the article itself never discussed this issue, which means the editor didn't pay attention to it, which means the review did not pick up on it. If I were a reviewer, I would say, explain to me what the hell has come to the attention. If you don't know it, discuss what the potential biases would be. In which way? It's going to overestimate this thing, or underestimate the things, or it's going to be random, right? What does it mean? So, this comes to the issue of so-called, all the data creation. Like, these people report these data, right? How do people know? Now, what's interesting, I tell you, this article, the methodology they developed was great. When they run the methodology, they actually, they're trying to see the historical change of the trend of the terrorist events. They actually detected there was a change of the trend in 1998 January, which is the time the data collection method was changed. So the algorithm was able to detect a pattern, except the pattern itself has nothing to do, at least most of them will agree, with the real change in the terrorist events. Because at the time, somebody realized that was a terrible way of collecting data, so they implemented two things. First, the event can be included only after retrospective confirmation by two institutions working on these terrorist things. And the second, they had to satisfy at least 5 out of 6 criteria. So at least they started setting up a criteria. So that methodology, whatever the data mining did pick up a pattern, but the interpretation could be entirely wrong. The scary part is though, if we did not know this part, I'm quite sure you will have social scientists, political scientists, everything, find all kinds of reasons why in January 1998 there's a sudden change of the terrorist event. I'm quite sure you can find this. You can look at it, geography, you can find the reasons, right? Humans are very good to fit these stories, right? Okay, so that is one. So as I said, there are all kinds of questions you can ask. Now, I'm going to skip this one, this interesting one. I'm going to go to this one, okay? Another fancy one. Machine learning approach to identify threshold in a heat health warning system, okay? This is a study from Canada. It's a really quite good article. What they're trying to study is, whenever the summer comes, the heat waves. When the heat waves comes, the government often, when the heat is too high, they will issue warnings, because the warnings will help, for example, set up all kinds of emergency protocols and helping particularly the senior people or having people have disease to kind of cope with the heat. But nobody was studying whether these thresholds were setting properly. Did you set too high, too low? So they want to do a study, say what is these things are, how do you see whether that is right or what's the impact of that? So that's all correct. And then, so what is their data? They want to seek in data-driven threshold to trick heat wave warning for serious citizens, right? So here's what the data they said. We considered daily data ranging from May to September of the year 1990 to 2004 of several administrative health regions around the city of Montreal, Canada. Okay? So that's what they're trying to data. And here is a key, there's one sentence. The data they have, that's the only sentence in the article, talk about this thing, they never said anything about this. The data are daily count of all causes of deaths in Montreal region. Okay? Now, again, when I teach this course, when I use this to teach a course, this will be a moment that I'm going to engage lots of discussions. Like, what problem do you see with this? Okay? I don't have too much time, but I still want this is key. I do want to, particularly students, like, what do you see the problem with this? Do you think now, do the data mining process as I'm promoting, think critically, what do you see the problem with this particular data? What other, anyone? All cause of deaths, okay? You say, well, all cause of deaths may or may not due to the heat, right? There's all sorts of problems. Now, this is the one that actually is interesting because whenever this thing happens, like when the pandemic happened, trying to figure out how many deaths due to COVID is not easy at all. There are direct cause, there are indirect cause, but you can look at in a period, what's the excess deaths in the period. That is a valid thing to look at. There's something collectively, whether indirect or directly caused during the period compared to the historical data, right? So all cause deaths is obviously, does not tell you what really happened, but it could be a good approximation to think about the impact of the heat wave, right? So but that itself is definitely one. But there's another thing here which should bother you. Yes?
Multiple administrative regions, are they counting in the same way?
Over the time, right? That's very important because it's historical data. So whether these modules, yeah, that's a very good one. Yes. Particularly, anytime you look at something over the time, you shouldn't worry about has the data collection protocol has changed over the time. Because like the previous one, it's easily to change. They cause all kinds of trend problems. Okay, so that's a good one. Anything else here? Daily count. Who said that? Yes. What's the problem with that? Go on. You're absolutely right. Are you a student here? Yeah, I'm busy saying that after you answer correctly, you can graduate. I tell you can graduate. You're absolutely right. When they say daily count, right? Okay. When a city collects data or region collects data, when you die, your data does not come to the city immediately. There's always a reporting delay, right? Now the reporting delay typically is of few days. Like in the current CDC data on the vaccination, which I'm going to talk next, if I still have time, it's about 5 days. But if these daily count, you need to know whether these daily count are the deaths happened on the day or the deaths reported on the day. That may not be a big issue for many other studies. But for correlated with heat waves is usually about a week, 5 to 10. You will be just miss the correlation, right? If those things are delayed. Now, it's a very simple issue. When I blame the journal, the reviewers, there was not a single sentence. You could just explain that the daily count is the reported one, or this one is after corrections, right? But if someone had not thought through this thing, not reporting that this entire analysis could be actually really underestimating what the real impact is. Right? So that's the kind of thing I call the data mining. It's a lot of questions, a lot of just experience. The reason I thought about this issue is not because I know this so well. I used to work on the age reporting delay to the CDC database. And I know the reporting delay itself is really highly correlated with how poorly the places is. So that's another issue. These reporting delay themselves could be highly correlated with where the areas maybe you need the most help or people have the most deaths because they're not getting access to it. Okay? So, but these are issues, as you know, that data, any fancy deep learning, whatever, they're never going to pick up those issues, right? Because the data's there. The data won't tell them. There's no way the data won't tell them, like, unless you put that kind of contextual information. But as a human analyst, that's the other thing probably the humans always needed. Good news for all of us, right? Machine cannot replace us, and machine cannot do things without you feeding them. Okay? And I hope that these are enough examples to show you what I mean by this. Okay, so another example I'm going to skip. So I sort of was going to call this, and I'm going to switch to the next one quickly for maybe 10 minutes. This whole thing, what I was doing, I feel like it could be fun. It's very much like a detective, right? What you do is you read the thing, you start thinking about, what should be there, what's not there, what is things. So I, quote the Xiao-Li because I think this is a good point, right? You see, but you do not observe. The distinction is clear. A lot of times we just, machine can see all the data, do the patterns, but they are not in a place to observe what's really behind them. And that is our human job. Okay, so the first part I was really just trying to tell you all these things in terms of how the seemingly very good study has all these data quality issues. Again, I'm not necessarily blaming the author. Some of them don't even know what the data, how they're collected. But as the journal and as the reviewers, we should do a better job. Now let me switch to the other ones if I still know how to do that. Okay, I got that right. Okay, good. All right, and then so the next one we'll talk about is, and quite a few of you I know in the audience have already heard me to talk about this thing. If I know how to get the full, where's the view? Full screen. Okay. So this part was really my working back in 2018. Was working on this, trying to measure data quality, particularly in the survey bias, because we all know 2016 election results surprise everyone, regardless whether your ideology. Everybody kind of surprised because all the prediction is Clinton surely going to win, and then what happened, right? So I basically was working on that, and later. Quite a few researchers, and some of them I did not even know them, they basically say, well, whatever I've done could be used for the vaccination study. So that's why I actually joined this study. We published a paper in Nature. So this part I'm just going to do quickly. These two examples. One is election. One is on the survey. And for those of you who have already heard me here many times, you can certainly to check if I say things consistently over the time. Okay. So this is the part I want to, even I don't have time, I want to spend a little bit of time with the audience. This was the 2021, and when the vaccination started being available, there was a great interest to estimate what's the percentage of the country in the United States has been vaccinated. At the time that there are four results you can look at. On the top is the blue one, which is the Facebook survey, working with Adelphia Facebook survey. It's a survey of the users of Facebook, okay? And it's about 250,000 samples per week. That's a very large sample size for any kind of polling situation. You never see a political survey with 250,000. That's the blue line. The green one is the census household pulse survey, conducted by United States Census. It's about 75,000 per week. It's still pretty large. Okay, that's a green line. The orange line is it's called a panel survey by Exo Ipso. It's about 1,000 people every week. That's the more regular survey we see. And the gray line is the CDC data. Is coming from what CDC reported, corrected for the reporting delay. Because CDC data, they have about 5 days reporting.
I'm going to see a show of hands from this audience that if that's the data you see, and you want to really know what's the vaccination rate in a country, other things, which one are you going to trust most? How many are going to trust the Facebook one? Come on, this group is too good. How many trust the Census Bureau one? Okay? Census Bureau, right? They know what they're doing, right? They do. Okay. How many trusted the actual Ipsos ones? Okay? You guys would basically trust nobody. Which is a good policy, good thing. How many trust the CDC data? Okay? For obvious reason, right? CDC is not a survey. They do a national, they know how to supply everything. But let me ask you the following question. Answer me really seriously. If the CDC data was not there, if you're given these three, which one you would trust most? Which one? Facebook? Right. I think most people would say, well, you know, Facebook would probably know the bias, right? Okay, because Facebook, I always say, the Facebook Republic is not the United States, right? Okay? But the Ipsos, well, you know, it's 1,000, you know, it's probably too small. And the Census Bureau, we trust them, obviously. And they're in the middle, sitting right. Okay? That's what you would have done. And we will be all wrong. Entirely wrong. What do I mean by entirely wrong? Look at the bars. The actual Ipsos, these bars, these are surveys, these are actually standard errors according to 1 over square root n calculations. And it's the little sample size, not the population size. Census Bureau has these little bars. Facebook ones have a little bar there, but they're so tiny you cannot see them. Why? It's 1 over square root of 250,000. Do a quick calculation, you know how small that is, right? With the CDC data, we now know that cannot be trusted. In fact, Census Bureau will tell you, don't trust their data. Why? That was a pulse survey. Pulse survey, they need to quickly reach out to people. Their survey frame was 144 million households. There's 144 million households in the United States. They were only able to reach to 116 million households. The 20% household they cannot reach to are exactly where those people living in the places hard to access to, and exactly places you do not have the vaccination. So they know they're biased. Okay? But I want to also ask you, there's something very disturbing here. It's that the larger the sample size, the further away from the truth. And is what I call the simple paradox. What I call it the big data paradox. Okay? Yes? Okay, 5 minutes. Give me 5 minutes, all right? Okay, in the 5 minutes, I'm going to do something very quick. So how do I explain this thing? First, the most important is you realize all these bars are calculated according to the sample size, not the population size. Why can't we get rid of the population size? Statistics take this for granted, right? But it's actually, you have to think about, this is actually very crucial, like why the population size does not matter. I always use this tasting soup analogy, right? And I found these cube soups, tiny, big ones. Whenever you taste the soup, all you need is just a few spoonfuls is enough as long as you mix them well, right? Because that's homogeneity. Once you mix them well, the size of the container does not matter, right? But in real life, you cannot really mix in soup. We create the randomizations, right? That's the initially statistically on average. But the real problem is that what happens if we fail to stir well? Okay, and then, so basically what I did is trying to create a quantity to say what happens if you do not stir well. And the thing is, like when it's simply representative, it's great. That's homogeneous. But when it's not, it's really bad. So okay, so here is let me use the election as an illustration. Suppose you have n number of response in an election survey. Capital N is the number of, say, voters in the United States. I'm going to creating this formula. Bear with me even in 5 minutes because it's important to understand this formula before I show you the grand results. Suppose for each of you, whether you're going to vote for candidate A or let's fix A. Okay, let's say A is whoever, not whoever. A is a fixed person. Okay. If you're going to vote for A, call it 1. If you don't vote for A, it's 0. It could be you don't vote at all. I just dichotomous and stuff. And suppose you're asked to report whether you're going to vote, who you're going to vote. I equal to 1 if you report honestly. I equal to 0, you refuse to report. I'm not dealing with a problem where you lie. Lie is too hard, okay? Even without lie, if you refuse, not lie, but you refuse. So here is the key formula I'm going to show you. The key thing is that I'm going to write the sample average, not as the usual, just simple average. I write as the ratio of 2 population average, right? Because if I equal to 1, someone is included. If I equal to 0, someone is not included. So writing this way, that's the same as the sample average. Is that clear? Because I equal 1 or 0, okay? The reason I do this is I explicitly include R, which is whether you can include or not. And that has become a key story. Because once I do that, I have the following results, and then it should be quite a trivial, particularly for the statisticians, because this is the sample mean and this is population mean. The difference between them is the exact error. But if I write it this way, I take a common denominator, then you will see the numerator becomes the average of product minus product average. And the statisticians will recognize that's just the covariance. Once you get a covariance, you divide by standard deviations, you can do this. By the way, I'm not assuming anything random. This is a finite population calculation. It's simply the correlation in the exact population. So there's nothing average here. This is exact results. But why do I make this so complicated? Because once you look at these 3 quantities, you realize what's happening. The first quantity is simply the correlation between R and X. Is that whether you are reporting or not, is how that correlated to the answers you would otherwise give. And that correlation, if it's a randomized sample, that correlation is practically 0. But if it's not randomized, if you have self-selection, that correlation can be large. Okay? So that's the one, is a measure how things are representative or not. That's the data quality measure. It's a correlation. Is that clear? Okay? The second part is simply, from the pre-formula, that's a data quantity issue. That's like how many people in it, how many people not in it, okay? The one thing is very important to realize, this thing can go to 0 if the little n very close to capital N, but even little n is half of the capital N, this quantity is still 1. So it would take an enormously large sample to overcome the bias if you rely on the sample itself, rely on size itself. The last quantity is simply the standard deviation of the X in the population. Has nothing to do with the survey sample itself, but it measures the problem difficulty. What do I mean by that? If in the population everybody all agreed to vote for the same person, you only need one person to tell you what's the truth. So the homogeneity here is measuring how hard this problem is. Okay? So why do I do this? Because this way it separates the problem of where this error comes from. It comes from the lack of data quality or lack of data quantity, or the problem is difficult. Okay? So you can make any one of them equal to 0, the whole thing will be 0. So what do I do this for? Because I want to show you what is the effective sample size. Because if you have something as a data defect here, so you can see that if it's a single random sample or probabilistic sample, this has to be on the order of 1 over square root of the capital N, not little n, in order to cancel this. Otherwise this thing will blow up. So the only way this can be controlling without relying on the capital N is if it's on order of 1 over capital N, which is very, very tiny. But in practice, when people self-report, this number is not going to be 1 over capital N. So I'm going to show you, say, okay, I'm going to look at effective sample size, which means that if I have a data set with a defect, okay, I want to say what would be the equivalent of single random sample with the sample size that they give the same statistical errors. Because that's what is easy to understand. And this is where the surprise comes in. So you can just solve this thing. You can see approximately it depends on the row, the data correlation, as well as the fraction of the sample size. That's very interesting. The effective sample size does not depend on the n only, depends on the fraction. That's why the capital N kicks in. Why do I do this? Okay, let's look at from 2016 elections, because after election, I know what the truth is. And I know from surveys, we use the YouGov survey, I know what the survey results is, and all these numbers can be calculated after the survey, so we can calculate what the row is. So when we asked the question about are you going to vote for Clinton or not, we did 51 rows. Every state has 1 row. You can do by state-wise, plus DC. So the 51 numbers give you this histogram. Okay? You can see they're centered around the 0 as they should, because if it's a randomized sample, people do not lie, if they do not have a bias reporting, you should have center around 0, you have a little bit of spread. That's expected. Okay? And then this spread is on the order of what would be predicted by the theory. Guess what happened if you ask a question about Trump? You see the bias. You see the little bias, right? Now the bias actually was saying, it's very small. The bias is saying that it's about a 0.5% correlation, okay? But remember, the corrected one is not a 0.5% correlation. It's the next order of magnitude. Now I'm going to show you the last slide, and I'm going to stop, okay? The last slide is very important. How much damage was done by this 0.5% correlation? Not a 5%, 0.5% correlation. So I'm going to put in, here's what I did. I look at all the surveys, all the media, radio, TV station, they did lots and lots of surveys. If I collect all of them, think about the sample size, as an upper bound, they collectively probably is up to like a 1% of the voting population, which is 2.3 million people. That's a lot. 2.3 million people means what? Means about 2,300 surveys, each with 1,000 respondents. That's a lot. Think about survey work, right? Now, with 1% opinions, but I know retrospectively has a 0.5% correlation, let's look at what is the effective sample size with 2.3 million people. Oh, we know it's going to be less than 2.3 million, but how small that will be? Anyone want to guess it? Those who have heard the answer, let me give a talk, you shouldn't answer. Anybody else? What would be the effective sample size according to this calculation? Is it going to be on the order of millions, hundreds of thousands, 10,000s? What's the range you're going to guess? Any guess?
70,000.
70,000. Okay, you're thinking about U.S. Census Bureau. 70,000. Okay. No, that's already. I mean, if 2.3 million get to 70,000, it should be still very alarming, right? That's a huge reduction. Okay, but you'll be surprised. It's about 400, and that is not a factorial sign. So basically, that 0.5% correlation has killed 99.9% of the data. That's why I want to show the mathematics. Otherwise, you say, well, you get out of here. This is some arithmetic error, okay? It's not. There's no mathematics in it. Here's the real story here. I'm not saying 400 people is not important. A good survey with 400 people still get a pretty reliable answer. In fact, in 2016, Clinton still won the popular votes, right? But imagine yourself working for Clinton's campaign. If you were told that 2,300 surveys, each with 1,000 people, they all tell you you're going to win, you can say stop campaign, which probably they did. Now visiting some swing states. But if you tell them like, that was only based on 400 people, you're not going to stop yourself. It'd be crazy to stop yourself. I just show you mathematically and empirically, they have exactly the same statistical information. And that's the importance of looking at the data quality. So let me really stop this because we need to leave time. I'm going to just show you that for this survey data, we did the same calculation. The 250,000 thing in the end, the effective sample size, depending on time, is less than 250, sometimes down to 10. Okay? Now you're not going to write a paper about you have survey results with 10 people, right? So let me finish. So the big data paradox is that if we don't pay attention to data quality, the bigger the data, the sure we'll fool ourselves. Why? Because your confidence band, you set it in the wrong place, and your confidence band is so tiny, you have no chance to get it right. Thank you very much.
Thank you for delivering this great talk. We are receiving many questions on Slido, and we might pick some highlights. So the first question is how to get other fields to care about data mining. Statisticians usually make caveats about data quality when doing meaningful analysis as opposed to developing methodology.
It's a terrific question, and I do have an answer to it.
because this is because I work with all these, all these different authors from different fields, right? The way you make sure people care something is to convey to them that what will hit their pocket, what is their baseline, okay? Because, if you talk to a business person, they may or may not understand all those things, but if you convey those things to say, this is how much dollar you're going to lose, they're going to listen to you, okay? Seriously. And if you talk to other industry or other business mostly money is the bottom line, to be honest. That's if you're going to convert, that's the common currency, right? But there are other things. For example, physicists. I know there are physicists here, particularly these particle physicists. I work with some of them. They told me they do something incredibly serious. They do something called a blind analysis. Their blind analysis is not what blind analysis. It's not just say you put some data aside. Then we check later. When they call blind analysis, they do set the data aside. Then they do everything check on whatever the rest of the data, whatever the model they built. They tell themselves that they're going to apply the model to this blind code, let's say 25% data. Whatever the conclusion you get there, that's a conclusion. You do not get to go back to say, oh no, I have to redo this model, or I have to wait. You don't get to do that. Okay? So I asked them, I said, how did you guys develop this so serious thing? Because it's hard. Every time they do that, they're very nervous. There could be years' work, and in the end, there's someone holding there and say, let's see. If that's not significant, it's not significant. Well, they say Xiao-Li, because our experiment is so expensive, it takes so long time. It takes 40 years. So they really want to get it right. Right? So the bottom line is that you need to find a way to communicate them in a way they understand the consequence of that. And that's not always easy, okay? But without that, it's just like we just said, keep telling them. But it's much more effective finding some metric, finding something they really care about.
Thank you for answering the question. But how can we find the incentive system? Because you may be penalized for sharing the detailed confessions, and it may hurt your publication chances.
That's a good one, right? But now we talk about incentive, right? Because as you said, you're absolutely right, whoever asked the question, that currently, that's why I was right now saying, currently I know this is not really practical, because most of us say, why do I do this, right? But this is what I'm going to push the editors myself, funding agencies, universities, right? If we really care about these quality issues, and this is where, we do have quality in control, right? It's not like you publish any article. Why do we look at articles and which journal you publish? Well, that's because the journal indexed the quality. So I think the journal will be really one place. I would push hard and say, you know how journals started having some sections on talk about reproducibility, right? Why not pushing the journal and say, for these data, you need to have a section on data quality. In fact, since it's been happening, for example, I know, Mike Stein is now the editor for the JASA, case study, right? Because I think he implemented a new policy, not a data quality per se, but I think the policy is that if you want to publish case studies, your data set has to be a new one. Okay? That's a policy, because we tend to use some old data set to illustrations, right? And that's not a serious case study. So journal can do things to make a change. It's not going to be easy, it's going to take generations. But I guess if we take care, if we worry about those things, which we should, but my worry is really, as all the machine, all the stuff gets, so everything automated, this is almost our last front to hold it, because there's no control. If the data is bad, these algorithms are going to find whatever the pattern is in the data.
Thank you, Dr. Meng. And unfortunately, we need to wrap up our Q&A session.
Since we started kind of late,
Yep.
allow for another 4 or 5 minutes.
Okay. Then we have a lot more questions from the audience, but I think we can ask one more question. So decisions that were made when collecting the data can be very subjective, and your colleagues may not agree with your decisions. So in such case, what are the things you can discuss to achieve agreement or come up with a better decision?
Oh, that's a terrific one. Yes, I was actually debating even with myself, right? When I was doing that data set, like which one is, yeah. I think that is the one, you know, it's really related to something else that we, in our training, we don't emphasize much yet, which is that when you do teamworks, right, there's a lot of things we need to communicate with each other because people disagree with you because they may have different metrics. It's usually because they care about something else. And this thing also happens quite a bit about not just even in a particular, you know, even people agree on a particular data set. I'm talking a little bit about like imputations. When we do imputation, we need to worry about how the people are going to use data later. And this will be, you need to understand what other possible analysis will be used. So I think that these things will be, like everything else, it's going to through a negotiation, through a compromise. But what's important during that conversation is you need to lay out clearly what is your metric. Why do you argue for that? Because you say, well, I care about this part. For example, I say, I care about data privacy, right? You need to lay out that. So often these negotiations become kind of a, sometimes not very, very constructive. It's because people have different metrics in their mind, but they don't lay out, and you argue with each other. Everybody arguing with respect to their metric. But you first agree on what the metrics you need. Before you discuss about the quality of data, you probably need to say what the criteria we care about. And this is actually important because if you do not discuss that, you tend to have overfitting later. Because you discuss the criteria first. Okay, once we agree on the criteria, then you discuss this and say, did you say that you agree on that? Okay, otherwise, no, I changed my mind. Okay, now sometimes we do that too. But if that you change your mind, you should also find a reason why you change your mind. But lots of these discussions, I think, is a part of the training that we typically don't get from doing the regular homeworks because you don't participate in that kind of thing. But for those of you who have chance, particularly with your professor, be part of a collaborative team, listen to other scientists, that's where you actually learn those things. You know, scientists come with very different, we care about statistics, we care about creating methods, publish articles, right, those things. But others care about their articles. We talk with industry people, they will care about, you know, care about the bottom line. I tell you one example. I had a paper in HDSR, again, Harvard Data Science Review, from the North Carolina State University. They have a lab which is industry, government, and academia, three kind of a group collaboration. Incredibly interesting. They also told me like these meetings are incredibly interesting. When they get in, the researchers were just very anxious, like when can we get the data, you know, to write up these articles. And the industries obviously care very much about when you're going to deliver all these, you know, product. And the government part is like how to make sure these policies are followed. I mean, everybody has their different stake. And that is the kind of thing, more and more as we do that as we get into this kind of data science space, because it's very hard, to be honest, these days to do any serious analysis or anything by yourself. It's all teamwork.
Thank you. Questions are still flowing through Slido, and we have time for the final one.
Okay.
What are some suggestions you have for authors to showcase their efforts on data mining?
Well, I think that this is I think again, we need to provide incentive for people to, just like how when we evaluate articles, right? Often we evaluate articles, we look for people discuss, you know, beyond their methodology, right? They discuss the limitation, discuss their deep thought. So we need the journals to encourage doing those things. So this being part of saying that if you do those kind of things, that means your study is more serious. Because you think more about the data quality. And good journals do ask you about this. You can't just say, I use some data set without explaining what the thing is. It's just what I'm worried about is if you look at this percentage of how they devote to the discussion, it's a lot less than they talk about computation, talk about simulation, talking about all kind of stuff. It's usually one paragraph, but I think this really needs to be enhanced. Because if you look at how dirty this thing is, it's really far more dirty than many other things. But again, I understand the question. At this moment, the incentive is not that much. So once we do, just like anything else, like professional society can help. We can have, you know, invited sessions, just talk about data mining. You know, because to me, it's actually very interesting. It's very like detective jobs, right? You know, and if there are some people should be their job. I know it's not a popular job. Their job is to pick up on other people's study. Okay, there are people who actually love to do those things. And now I know it's not going to make you lots of friends, but if you think about how society, like we have, we have the political system, like three bodies control each other, although that's not really working these days, but that's a different story. Right? So you can build these systems trying to increase those things. But again, I want to acknowledge that it's not easy at all. But I think certainly for anyone, if you write an article, those things send to HDSR, okay? I will publish those articles.
Thank you. Thank you again for delivering this great talk and answering all our questions.
And also, we know that we have many questions that could not be covered in this session, but this lecture is followed by the reception, which is happening right after this at the third floor in this building, Thomas Building, and you can have a further discussion with our guest speaker.